Consider the point A is 3, negative 3, 1. B, 0, 3, 2. And C, negative 4, 2, 0. Find the area of parallelogram ABCD with adjacent sides AB and AC. Okay, so let's find the adjacent sides AB and AC. So for these vectors, we need to subtract B minus A. So you have 0 minus 3, 3 minus negative 3, and then 2 minus 1. Then for AC, it's basically C minus A. So it's negative 4 minus 3, 2 minus negative 3, 0 minus 1. Okay. Now we want to find the cross product of these two vectors. So with the cross product, the first row is always going to be I, J, K. And then we're going to put vector AB first, since that's the first vector here. It's negative 3, 6, 1. And then vector AC. Okay, so take the determinant. So hide the first row, first column. We have negative 6 minus 5. That's going to be negative 11. And then minus J. Okay, hide the first row, second column. So 3 plus 7, that would be 10. So I'm going to put actually the 10 in front. So let me just write this out nicely. It's negative 11I minus 10J. And finally for K, we hide the first row, last column. Negative 3 times 5 is negative 15. Negative 7 times 6 is negative 42. So negative 15 minus negative 42, that's going to be 27. So that's plus 27K. And then finally, since we want to find the area, we have to look at the length of this. So find the length of the cross product. So that's going to be the square root of each of the components squared. And simplifying this, we get the square root of 950, which is also same thing as 5 square root 38. Let line L be x equals 2t, y equals 0, z equals 3. And we're going to let line M be x equals 0, y equals 8 plus s, and z equals 7 plus s for some constants t and s. Determine whether the lines are equal, parallel but not equal, intersect, or are skew. Okay, so first let's compare these two lines. So let's compare the x's with the x's, the y's with the y's, and then the z's with the z's. Okay. All right, so from the first line here, this means that t is 0. The second one, s has to be negative 8. And the last one, s has to be negative 4. So here we get two different answers for s. So that means that they can't be parallel, and they certainly cannot intersect. Because if they intersected, there would be a solution, a nice solution for this. But you got two different answers. So it's definitely doesn't intersect. Okay. And the direction of line L you just look at think of it as like the slope. You know, it's the number in front of the t. So here it's 2. There is no t here. There is no t here. So it's 2, 0, 0. And then for line M, there's no s here, but there's one s and one s. So it's 0, 1, 1. So clearly, these are not parallel because they're not going in the same direction. So they're not parallel, they're not intersecting, so they must be skew lines. Next one, compute the derivative of the vector valued function r of t. So that's going to be ln of x squared plus 4 over x minus 5I plus sine squared j plus t squared plus 1 quantity squared k. Okay, so the derivative, you just need to just take the derivative of each component. But first, I'm going to make it easy by breaking this up. So ln of x over y is the same thing as ln of x minus ln of y. So in this case, it's the top is x squared plus 4, the bottom is x minus 5, and that's going to be for I. And then for j and k, we're just going to leave it the same. And this is just an intermediate step just to make the algebra nicer. Now we can take the derivative. So for natural log, it's 1 over the inside times the derivative of the inside. Okay, so it's 1 over x minus 5 times the derivative of x minus 5 is just 1. And that's times I. Now for sine squared, we have to use the chain rule. Bring down the exponent, leave the sign alone, take the derivative of sine. And then for same thing with k, bring down the exponent, keep t squared plus 1 the same, subtract 1 in the exponent, and then multiply by the derivative of the inside. And this one we're just going to rewrite. So this will be 2x over x squared plus 4 minus 1 over x minus 5 I. And this one we could just rewrite it as sine 2t just to make it easier. J. And we have 2 times 2t is 4t. So it's 4t times t squared plus 1 k. And this is our answer.